Hi everyone, Mr. Boltri here bringing you video 6.3 where we're going to talk about FAM law. So first, let's talk about the lab discussion that we had in class today. So the groups that did force versus acceleration found their graphs to be linear, and the groups that did acceleration versus mass found their graphs to be nonlinear, actually inverse. So when we linearize this and then write the equation for both of the graphs, we find that force equals the slope times the acceleration. And then the acceleration equals the slope of our linearized graph times 1 over mass. And then after much deliberation, we found that the slope of this graph actually equaled the mass, and the slope of this graph actually equaled the force. So force equals mass times acceleration was one equation, and then acceleration equals force divided by mass is the other one. And we actually found that these two equations were the same, and they actually were both force equals mass times acceleration, which you may have heard called Newton's second law. But I, using the commutative property of multiplication, like to call it the FAM law, just because that's more fun for me to say. But it's still the same thing. Force equals mass times acceleration, or force equals acceleration times mass. But before you write that down, there's one thing that I'd like to correct about this. So force equals acceleration times mass, or mass times acceleration, is close to correct. But remember all the way back to unit 3, when we had two children pushing on a box, one pushing to the right and the other pushing to the left. And so if they're pushing with equal force, the box maintains its constant velocity of stationary. It actually has an acceleration of 0. So here, this force is not actually any old random force. We actually have to look at all of the forces acting on the object and then add them together. So the way that we write that is the net force, or the sum of the forces sigma F. This is just the net force, which is all the forces added together, or sigma just means sum, which means you take all the forces and you add them together. So when you're writing the FAM law, make sure you don't forget to slip in a net for the net force or a sigma for the sum of all the forces. So now what I want to do is I want to talk about how Newton's second law really ties together all of the stuff that we've talked about up until this point involving forces. So the connection to the first law, well, first let's remember the first law, which is balanced forces give us a constant velocity, unbalanced forces give us a changing velocity. So what's this have to do with Newton's second law, the FAM law? So the net force, or then sigma force, equals acceleration times the mass. So here, the sum of the forces is 0. So we're going to get a 0 acceleration. That's constant velocity. Here, the sum of the forces is not 0. So we're going to get a changing velocity, which is a non-zero or positive or negative acceleration. So we can see that Newton's second law, the FAM law, is basically just a numeric quantification. It's a way to put numbers on the concept that was laid out in Newton's first law. So this will allow us to do some math, but the concept is nothing new. It is something that we've known all the way back since October. So I hope that you see how these two things are connected. Now let me show you how it's connected to Newton's third law. Well, let's remember Newton's third law, which is that forces come in interaction force pairs, which are equal in magnitude, opposite in direction, occur simultaneously, and follow the pattern by A on B is equal to by B on A. So remember we did an example where a big car crashes into a small car. And we said, well, which exerts more force on the other? Well, the force by truck on car by Newton's third law equals the force by car on truck. Let's say 6,000 newtons. And then before we said, well, how does that make sense? Why is that the way it is? And we said, well, it's just because it is. But now we can use Newton's second law to explain actually why that is the way that it is. So if we look at Newton's second law and we actually plug in the numbers, assuming that this is the only force acting on the truck is going to experience acceleration of 0.25 meters per second squared, where the car is going to experience a much bigger acceleration of 5 meters per second squared. So and the reason that this is because we now know that the more mass something has, the less acceleration it experiences due to the same amount of force. We can think about our inverse graph, where the more mass it had, we saw that the acceleration got smaller and smaller and smaller. So we can actually use Newton's second law, the FAM law, to explain what's happening with Newton's third law, why these two forces, how they can be equal, but then we see such different responses from the truck versus the car. Is because their accelerations are very different based on the fact that they have different masses. And last but not least, last unit, we did a lab where way back in unit 3, we found the force gravity equals negative 10 times the mass. We called this negative 10 the force gravity multiplier. And then in the last unit, we found that the acceleration due to gravity for an object that's falling on Earth is negative 10 meters per second squared. Then we asked ourselves, are these two negative 10s the same? Some people said yes, definitely. Some people said maybe, I'm not sure. And some people said no. So here, if we look at the net force equals the acceleration times the mass, and for an object that is falling, with the net force, the only force acting on it is the force gravity. So then we can say the force gravity equals the acceleration due to gravity times the mass. Force gravity equals negative 10 times the mass. This negative 10 is actually, yes, the acceleration due to gravity. So those two, this negative 10 and this negative 10 are the same. This force gravity multiplier is actually not just a random number multiplier. It is the acceleration due to gravity if an object were to be subjected only to the force of gravity. Now, obviously, for example, my laptop, force gravity is pulling it down, but my table is pushing it up, so the forces are balanced. But if the only force acting on an object is gravity, then it falls with an acceleration of negative 10, and that's how we find the magnitude of the force of gravity on an object. So these two numbers are the same, which I think is pretty cool and an application of Newton's second law, the FAM law. So we are going to do lots of FAM law practice problems in our next class. You can ask any questions you want. Please write those down in your notes and put a star next to them so I can answer them in our next class. But for now, this is Mr. Boltri wrapping up video 6.3 on the FAM law, and go Bears.